Let's look at the edge application orchestration scenario. This scenario of the demo showcases three major capabilities provided by the Ether solution. One is proactive resource allocation, which means the system should be able to anticipate changes in network and the system states in order to allocate resources, thus minimizing resource over-provision and excessive energy consumption. The other is proactive application placement, which means the application is not stationarily placed on a single node, but there should be a capability to migrate these across different nodes depending on where the situation is more conducive. And the other is a zero-touch closed-loop orchestration, which means the system should be able to monitor, decide, and act autonomously with minimal human intervention. Then we look at the architecture of the demo. We have two cloudlets, Cloudlet A and Cloudlet B, which are emulating distributed clusters, and these are running the different applications, including the monitoring components. And then we have a moving aircraft, which is experiencing different SNR values to the different cloudlets and generating traffic of different sizes. And then we have the analytics module, which continuously observes and makes prediction regarding the SNR to the different cloudlets and the traffic size as well. The analytics module passes these to the decision engine, which decides when it is required to scale and whether the scaling has to be performed up or down, and also to trigger when it is necessary to perform migration of the application and determining the node to which the application should be migrated. This passes the decision as an action to the Ether orchestrator, which is implemented using the nearby one edge orchestrator, which then enforces these into the underlying infrastructure. Now let's go into the demo. Here we see the nearby one graphical user interface, which is going to be used to manage the different deployed application and the distributed infrastructure. Specifically under the Ether organization, we should see the components that have been already onboarded, specifically cluster A and cluster B that have already onboarded, which are also visible here. Then the components to be deployed, we have the decision engine and the Collins application that are going to follow. And here we see the configurations. So initially we deploy the decision engine and we are going to deploy it on cluster A as the target cluster. And we can see the progression here is progressing, but now in sync condition, which means active and running. Once that is stable and running, then we go and deploy the Collins application, and we're also going to choose cluster A as the target application, target deployment cluster. Its progression here, it's progressing now. It's in sync, meaning it's also active and running. Then here we could check the status of the decision engine. The one replica is active and running. And here we now check the status of the flight application, which also is active and running for the two replicas that were initially deployed. And we check the logs of the decision engine here. And we can see it's still waiting for the channel quality matrix, which is actually the SNR values here in that case. Well, in the Grafana dashboard, the system has started to evolve. Here we can monitor the total response time. Here we monitor the CPU utilization, the file size, the SNR of cluster A and cluster B, the power consumption of cluster A and cluster B, and these are the number of replicas that are currently being executed on the application. Interestingly, here we observe that the traffic demand is increasing, which is consequently causing an increment in the CPU utilization of the node, and also total response time therefore is increasing. And we notice here that response time is approaching the 1 second threshold that was set, in which case the decision engine should be able to make this prediction and increase the number of replicas from 2 to a higher value in order to term this quality of service violation that is pending. Indeed, of course, the predictions are happening here. We can see that the replicas need to be increased, to 8 has been predicted. Therefore, here we should be able to see an increment from 2 to 8 replicas. Indeed, it has been done. And once that does happen, we can see that the response time stabilizes, the CPU consumption also decreases, even with an increment in the demand size. But here we notice another pending violation coming in, but this is resulting from the fact that the SNR on Cloudlet A is dropping, while that of cloudlet B is improving. In this case, we expect a decision engine to make this prediction and tame this impending violation as well by performing migration, which actually has happened here, because we see the power consumption on cluster B is increasing and the cluster A power consumption is dropping to 0, which means the application is running on cluster B as seen from here, which means the migration has been triggered in this case. Indeed, we can check what is happening on the cluster B, is where the application is running here by these logs as shown here in this case. And it's being triggered even before the SNR exceeds that. So if you check even the interfaces, we can see that the application is running cluster B, which is the only available cluster at this time here. So the migration has been triggered in this case. So what is noticeable to note here, that with the system evolving through this evolution, we were able to maintain the response time within a given bound without exceedingly allocate excessive resources. And these changes, both resource scaling and migration, were being triggered in a proactive manner. For instance, here we can see that the migration was triggered at this point where the application was moved from cloudlet A to cloudlet B, where we see also the available node at this instant is cloudlet B. The key takeaways. Through this demo, we've showcased that the proposed Ether solution is able to, 1, anticipate performance issues before they occur, leveraging analytics, thus mitigating quality of service violation, but it's also able to adapt computing resources dynamically, mitigating resource over-provisioning and excessive energy consumption, and it's able to move application to the best location in real time, given an heterogeneous distributed network infrastructure. But we are also able to maintain strict performance guarantees with minimal energy usage. Moreover, we are able to achieve all the above through a fully automated closed-loop orchestration framework, which enables reliable and efficient operation for safety-critical airspace communication as opposed to human-centric approaches.